Today we're going to talk about midpoint and distance formula and use the properties of midpoints and segment bisectors to calculate lengths of segments. So a midpoint is the point that bisects a segment into two congruent segments. So if we have a segment AB, point M is the midpoint, which means the length of segment AM and the length of segment MB are the same. Bisect means to cut a segment into two congruent segments, and a segment bisector is a point, ray, line, or line segment that intersects the segment at its midpoint. So here, if we take a look at segment AB, we can say that M is the midpoint of AB. So segment AM is congruent to segment MB, and the length of AM is equal to the length of MB. So if I told you that segment AB measured 10 units, you could tell me the length of segment AM and the length of segment MB, right? Because the entire length is 10 units, all you have to do is cut that in half, divide that by 2. So AM would be 5 units, and MB would also be 5 units. On the right, here we can say that line CD is a segment bisector of AB. It's the line that bisects the angle. It intersects the segment at the midpoint. So again, we can say that the length of AM is equal to the length of MB. So if I told you that the entire segment AB measured 27 units, you could tell me right away, divide that by 2. Segment AM is 13.5 units, and segment MB is also 13.5 units. So it cuts that segment right in half, splits it into two congruent or equal parts. So for the example, we want to use the diagram of the flat screen TV to find the length of WY. So we're finding this length here, WY. If ZX is a bisector of WY. So this segment here bisects segment WY. So that tells me that segment WV and segment VY are the same. We know that segment WV is 22 units. That means segment VY must also be 22 inches. So the entire segment is equal to 22 plus 22, or 22 times 2, which is 44 inches. So the length of WY is 44 inches. Pause the video and try the practice problem. So here we know point M is the midpoint of segment VW, and we want to find the length of segment VM. So this is the length we are trying to find. Because M is the midpoint, we know that VM and MW are equal. So we can set these expressions equal and solve for x. So we know 4x minus 1 must be equal to 3x plus 3. So we're going to use our algebra skills to solve for x here. We can subtract 3x from both sides. So we have x minus 1 is equal to 3. Then we can add 1 to both sides. So we get x is equal to 4. Now they didn't want us just to solve for x, they wanted us to solve for the length of VM. So what we're going to do is we're going to take x and we're going to plug it right into this expression. So VM is equal to 4 times 4 minus 1. The length of VM is equal to 16 minus 1, which is 15 units. Next, we want to identify the segment bisector of PQ, and then we want to find the length of PQ. So for number 1, the segment that bisects and intersects the segment at the midpoint is ray MN. Ray MN is our segment bisector. That means that PM and MQ are congruent segments. PM is 3.5 inches, so we know that MQ is also 3.5 inches. So to find the length of PQ, we're going to do 3.5 plus 3.5, which gives us 7 inches. Pause the video and try number 2 on your own. So for number 2, let's just say we have point N here, right? Our segment bisector is line MN. Because that segment bisector intersects the segment at the midpoint, we know that segment PM and segment MQ are congruent. They have equal lengths. So here we can set 3x minus 2 equal to 2x plus 2. And we can use algebra to solve. I'm going to subtract 2x from both sides. So we have x minus 2 equals 2. I'm going to add 2 to both sides. So we get x equals 4. They don't want the length of they don't want us to just solve for x. They want us to find the length of segment PQ. So what we're going to do is we're just going to plug in 4 for x. So we get 12 minus 2 plus 8 plus 2. 12 minus 2 is 10, plus 8 plus 2. So we get 20. So PQ is equal to 20 units. Next we have the midpoint formula. So the coordinates of a midpoint of a segment are the averages of the x-coordinates and the y-coordinates of the endpoints. So the formula to find the midpoint, we have x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. And our answer is going to be an ordered pair, right? Another coordinate point. So if we take a look at the first example, we have endpoints R is 1, -3, and S is 4, 2. We want to find the coordinates of the midpoint. So we can label R as x1, y1. We can label S as x2, y2. And now we just have to plug it into our formula. So here we have x1 is 1 plus x2 is 4 divided by 2. And then we have y1, which is -3, plus y2, which is 2, divided by 2. So we know 1 plus 4 is 5 divided by 2, and -3 plus 2 is -1 divided by 2. We can't divide 5 by 2 evenly or -1 by 2 evenly, so we're just going to leave our answer as a fraction. You could also write your answer as a decimal. So 5 divided by 2 is 2.5, and then -1 divided by 2 is -0.5. So you can either leave your answer as a fraction or a decimal. Pause the video and try the second example on your own. So for the second example, you should have gotten 1, -4. For example 3, we're given the midpoint of segment JK is 2, 1, and one of the endpoints is 1, 4. So this is going to be a little different. We're not going to use the formula here. Instead, we're going to use a little shortcut. So if we start with one of our endpoints, I like to draw the segment vertically, just so I know I'm staying in order. So we have segment JK with midpoint M. We know that the coordinates of J are 1, 4. We know that the coordinates of the midpoint are 2, 1. So now we have to see how many we had to add or subtract to get from J to M. So for the x coordinate, to get from 1 to 2, we had to add 1 here. Everyone with me? To get from an x coordinate of 1 to an x coordinate of 2, we had to add 1. If we look at the y coordinates, to get to a coordinate of 4, from a coordinate of 4 to a coordinate of 1, we had to subtract 3. So now to find the coordinates of the other endpoint, we're going to follow that same pattern. So we're going to add 1 to the x coordinate, and we are going to subtract 3 from the y coordinate. So here we should get 3. 2 plus 1 is 3, and then 1 minus 3 is -2. Pause the video and try the next example on your own. For the second example, you should have gotten an endpoint of 8, 19. X coordinates you had to add 3, y coordinates you had to add 11. Next we have the distance formula. It's used for computing the distance between 2 points in the coordinate plane. So the formula for the distance is x2 minus x1 squared plus y2 minus y1 squared. So for example 1, we want to find the length between the endpoints 2, 3 and 4, -1. So we'll use A as x1, y1. We'll use B as x2, y2. So here we're always going to use the same exact shell, right? So we have x2 minus x1. x2 is 4, x1 is 2. Then we have y2, which is -1, minus y1, which is 3. So now we can solve. So here we have the square root. 4 minus 2 is 2, so we have 2 squared, plus -1 minus 3 is -4, so we have -4 squared. We know that 2 squared is 4, and we know that -4 squared is 16, right? A negative times a negative is a positive. And then we have 4 plus 16 is 20. So our distance is the square root of 20. However, we can simplify this radical. We can break it up into the square root of 4 times the square root of 5. We know that the square root of 4 is 2. And we can't simplify the square root of 5 any further. So our length is 2 radical 5. Please pause the video and try the next 2 examples on your own. Check your work. So for the second example, you should have gotten radical 45, or the square root of 45, which simplifies to 3 radical 5. And for the last example, you should have gotten the square root of 40, which simplifies to 2 radical 10.